Dear friends, welcome to video lecture in engineering mathematics, and the topic is again Fourier transform. Right now there shall see some examples on Fourier transform. So here sine transform, cosine transform, Fourier transform, f of lambda is equal to minus infinity to plus infinity, f of t e to the power minus I times lambda t dt. This is in time domain, and the variable lambda, it is the function lambda in frequency domain. Let us see examples. The first example, find Fourier transform. Find Fourier transform of fx is equal to 1 for mod x less than 1, and this is 0 for mod x greater than 1, and hence show that 0 to infinity sin x divided by x dx is pi by 2. So let us solve this problem. Solution: let us find Fourier transform of this signal. This is f of t or f of u. I can take f of u is equal to 1 for u less than 1, and this is 0 for u greater than 1. So as I said earlier, this means actually minus 1 is less than u is less than 1, and this means actually it is minus 1 minus infinity is less than u is less than minus 1 and u is greater than 1. So something like this. So Fourier transform here, f of u or f of x. Fourier transform, basic definition, f of lambda is equal to minus infinity to plus infinity, or is taken as even function f of u e to the power minus I times lambda u t. Variable, you can take anything, it can be taken as t also, x also, it does not makes any difference there. So I just split this according as the function defined. Now here f of u is 1, so f of lambda is equal to, I just split minus infinity to minus 1, minus 1 to plus 1, 1 to infinity. So I am splitting as minus 1 to 1, 1 to minus 1 to infinity, u is greater than 1. So it would be something like this in the, this is u suppose, and this is f of u. Okay, so this is minus 1, this is plus 1. So here the function defined to be 1 means something, f of u is equal to 1. So it is this, f of u is equal to 1, f of u is equal to 1, and again it becomes 0 elsewhere. And if you try to, this is in time domain, u is the time or t is the time. You have to find out the function, its imaging frequency domain, minus infinity to minus 1. So it is 0. So I just reject these things here and take only under consideration minus 1 to 1. What is f of u? It is 1. So I put 1 there. Then it is e to the power minus I times lambda u du. This is equal to minus 1 to 1. And this I can write down cos lambda u minus I times sine of lambda u into d So this is equal to, I just integrate this cos of lambda u into du minus I times minus 1 to 1 sine of lambda u du. Now if you observe here, this is even function and this is odd function. What is meant by even function and odd function? F of minus x is equal to f of x in certain interval, then it is said to be even function, and f of minus x is equal to minus f of x, then that function is said to be an odd function. And if you observe this graph of the even function is symmetrical about y-axis, graph of the odd function is symmetrical about origin. Now if you observe, cosine is always even, sine that is odd function. So I can write down this as 0 to 1. 0 to 1 cos of lambda u du using the property of the definite integral, it is this minus a to a f, this is equal to 2 times 0 to a f if f is even function using this property of this. Now I integrate this, this is equal to 2 times, what is integration of this? Sine of lambda u divided by lambda limits 0 to 1. So I apply upper limit and lower limit here 2 times. Now if I apply, replace u by 1, then sine lambda upon lambda minus lower limit sine 0 is 0. So I am getting this as 0. So the answer is 2 times sine lambda upon lambda. This is f of lambda. This is f of lambda. 2 times sine lambda upon lambda. So this is the image of this signal under Fourier transform. Now let us see pictorially what will happen here. So if you observe, so this is the signal. It is constant signal, actually constant function. Its representation here, it is something like this in t domain or u domain, and if it is transformed to frequency domain, then here it is 1. So its image would be something like this. So you can just check out this image and draw the graph of this function. It would be something like this. So 0. This is in frequency domain. So this is the way you are having this kind of the transforms to transform certain signal in terms of from time to frequency domain. Now let us see more examples here. Okay, so the next example is find Fourier sine transform. Second, find Fourier sine transform, Fourier sine and cosine transform, FST and FCT for fx is equal to x raised to m minus 1, m minus 1. So let us see solution for this. Here f of u would be u raised to m minus 1 for x greater than 0. So I use Fourier sine transform, fc lambda cosine transform at 0 to infinity, f of u cos of lambda u du, and this would be something 0 to infinity. F of u means it is u raised to m minus 1 cos of lambda u du, and fs lambda Fourier cosine sine transform 0 to infinity, f of u sine of lambda u du, this is equal to 0 to infinity u raised to m minus 1 sine of lambda u. So we can find out simultaneously these two transforms here. So I just multiply, this is by I, this is 1 this is 2 and add up together. So, or subtract. So, what are we getting? This is minus fc lambda minus I times fs lambda. This is equal to, you are getting this as, here also it is to be multiplied by I. So, you may be getting this as 0 to infinity u raised to m minus 1 cos of lambda u minus I times sine of lambda u into du. So, we can write down this in the form fc lambda, which cosine transform minus I times fs lambda. This is equal to 0 to infinity. It is u raised to m minus 1 into e to the power minus I times lambda u into du. Now, as I said in prerequisites, we need to transform this in terms of gamma function. Do you know what is gamma function? So gamma function would be something like this: 0 to infinity e raised to minus t raised to n minus 1 dt. So this is kernel of the gamma function. So it is required to transform this integral in this form. Put I lambda u is equal to t. So u is equal to t upon I lambda and du is equal to dt upon I lambda. Limits would be same there, no change in the limit. So this will take the form 0 to infinity. U means t upon I lambda raised to m minus 1 e raised to minus t du upon I lambda. So I just simplify this. It would be something like this: I lambda bracket raised to m minus 1 and 1. This 1 means it is m there, and 0 to infinity t raised to m minus 1. It is m minus 1 into e raised to minus t, and this is well-known gamma function. So I am getting this as 1 upon lambda raised to m I raised to m into gamma m. This is gamma m. So I am getting this as, or this I can simplify further, gamma m upon lambda raised to m, and this I can write down cos pi by 2 minus I times sine pi by 2 bracket raised to m. So I can write this as cos of fc lambda. From here I just take it minus I times sine of fs lambda. This is equal to gamma m upon lambda raised to m cos of m pi by 2, in fact, minus I times sine of gamma m upon lambda raised to m sine of m pi by 2. Now what we do here, this expression, we just compare real and imaginary parts. We get fc lambda is equal to, this is well-known standard formula, or cosine transform of this thing here, n pi by 2, and Fourier sine transform fs lambda gamma m upon lambda raised to m sine of n pi by 2. So this is sine and cosine transform of the function, the signal x raised to m minus 1. This important signal actually for changing all the time the values x square, x cube, with straight line x square, parabolic signal x cube, to we can solve the polynomial signal, and this is the formula to find out sine and cosine transform of this. So there is one more example. Find sine transform, Fourier sine transform of fx equal to, problem number 3. Find Fourier sine transform of fx is equal to 1 by x or 1 by t. So this is hyperbolic signal, in fact, 1 upon x. This is called hyperbolic signal. And how to find out its image or its frequency image in the frequency domain? Solution for this, fx is equal to 1 upon x. So I can write down this as f of u is equal to 1 upon u. For x greater than 0, we have to find out this Fourier sine transform of f of u is fs lambda formula. This is equal to 0 to infinity f of u into sine of lambda d. So I just put it here, 0 to infinity 1 upon u sine of lambda d, or fs lambda. This is equal to 0 to infinity sine of lambda u divided by u into du. Okay. Now I just simplify this. Put lambda u is equal to x. So u is equal to x upon lambda. Du is equal to dx upon lambda. To simplify this further, limit should be same, 0 to infinity sine x upon lambda, and du is dx upon lambda. Okay, this lambda gets cancelled, and this is 0 to infinity sine x upon x into dx, and value of this integral, as I said in the prerequisites, it is pi by 2, and so this is required Fourier sine transform of 1 upon x. Okay, thank you.